For this lesson, I'm just going to walk through two proofs because they have some new reasons to use, and then the rest of them you're going to tackle on your own as much as you can. So we have AD bisects BE up here, and we have AB is parallel to DE. I want to prove that triangle ABC is congruent to triangle DEC. So this shouldn't be too bad. We're going to start with our given. So magically we have our given written down. AD bisects BE and AB is parallel to DE. So I want you to think about this statement here. AD bisects BE. First of all, these are segments. These are not angles. We are not talking about angle bisectors. And think to yourself, AD bisects BE. Which one is the knife? Which one is doing the cutting? If you think about that, AD is chopping BE in half. So that's what you have to remember. The only thing I can get out of that is that BC and EC are going to be congruent, not AC and DC. So here's my statement. BC is congruent to EC because that's the one that's being chopped in half by the definition of a segment bisector. Okay, then I have the bow tie, so I'm going to go ahead and get those angles just because that's easy. I can say angle BCA, you cannot say just angle C. Angle BCA is congruent to angle ECD. And that's because vertical angles are congruent. So I have those two. Now I have to get something else. I don't have any information on side links, so I have to deal with angles. AB is parallel to DE. So if you think about what you know about parallel lines, BE is a transversal. So this creates alternate interior angles. So I can say angle B is congruent to angle E. Now look at that. Why can I use just one letter here and just one letter there? Think about that. But I can just use one letter. Here's my reason. If parallel lines are cut by a transversal, you have to write all of this, alternate interior angles are congruent. You have to write that whole thing. That's enough, though, to say that the triangles are congruent, because if you look, I have angle, side, angle. So there we have it. We have triangle ABC is congruent to triangle DEC. Angle, side, angle is congruent to angle, side, angle. All right, one more proof. And then we do the rest together, or you do it in class. We have PA is perpendicular to AR. So PA and AR, I'm going to draw my little right angle symbol. PB is perpendicular to BR, so I'm going to draw that symbol. And AR is congruent with BR. So if we look at this, I want to prove that PR bisects APB. Well, to get here, that means we're going to have to get two angles congruent, which means I'm going to need to use CPCTC. In order to use CPCTC, I have to get these two triangles congruent. Just looking at the diagram, I can see that PR is congruent to PR. So let's see where that gets us. PR is congruent to PR. Do I have enough to say that the triangles are congruent? Please be careful with this, because what you have is side-side angle, and that doesn't work. What you need in that case is hypotenuse leg. So I'm going to use my perpendicular lines, and I'm going to say I have right angles and then right triangles, and then use hypotenuse leg. So it takes two steps. You've got to say angle PAR and angle PBR are right angles, because perpendicular lines form right angles. Then instead of saying they're congruent, you've got to say triangle PAR and triangle PBR are right triangles. Each contain a right angle. That's enough to say that they're congruent. Triangle PAR is congruent to triangle PBR. Hypotenuse leg is congruent to hypotenuse leg. Two more steps. If I label angle 1 and angle 2, I can now say that angle 1 is congruent to angle 2, and that's because corresponding parts of congruent triangles are congruent. Finally, you can say that PR bisects APB. And that's just by definition of an angle bisector. And that's it. So again, we get the triangles congruent, we use CPCTC to get the parts congruent, and then we use a definition for our final statement. And we're going to practice more of these in class.